right, so the warm-up for today, what we need to do, first of all, to simplify this square root of 28, we need to break it down into its primes. So prime tree, prime factorization tree, okay? So what goes into 28? 2 and 14. What goes into 14? 2 and 7. So I can rewrite this as 2 times 2 times 7. Okay, so I'm looking for pairs of prime numbers. I have a pair of 2's. So I can take one of those outside the radical. So this would be 2 square roots of 7. Oops, 7, not 6. Okay? So that's the answer to the first one. Okay, the second one you're going to do the same way. You're going to break this down. And I can break this down into 3 and 100. 100 is divisible by 25 and 4. 5 and 5. 2 and 2. So this is the same thing as saying 2 square roots of 2 times 2 times 3 times 5 times 5. What pairs of prime numbers do I have on this one? I have 2's and 5's, right? So I can take out a 2 and a 5. I already have a 2 on the outside. I'm going to leave it there. Just bring out another 2, 5, and then the inside what I'm left with is a 3. So 2 times 2 is 4, times 5 is 20. So you should have gotten 20 square roots of 3 for this one. Right? Questions on that one? Okay, when we're multiplying square roots, this is just like saying 12 times 8. We're just going to put it under the radical. Okay, and then when we do that, that's going to be the square root of 96. Problem is that's not simplified. So we need to actually simplify this 96. We know that 3 goes into 96 32 times. Okay? And then 32, you have 8 and 4. This can break down to 2 and 2. And then 8, you got 4 and 2. And then 2 and 2 here. I'm running out of room. So how many 2's do I have? 5 of them. So I'm going to write them out here. And then I also have a 3. So based on this, I have 2 pairs of 2's that I can pull out of the radical. So that'll be 2 times 2, and then 2 times 3 stays on the inside. And that would be 4 square roots of 6. Okay, the same rule goes for dividing that we did with multiplying. You could put the entire thing underneath one radical. So this would be 48 divided by 6, which is the square root of 8. You can break that 8 down into 4 and 2 and then 2 and 2. So you have one pair of 2's that you can pull out of the radical. So that would be 2 square roots of 2 is your answer on that one. Today our two main focuses is one, we're going to be adding and subtracting rational numbers or square roots, okay? So that's the first focus. Yesterday or Friday we did multiply and divide. Today we're adding, subtracting. And we're also going to do something called rationalize the denominator. So those are our two objectives for today. So the first one I want to look at here is we have a 4 square root of 19 and a 5 square root of 19. What I want you to focus on for a second is this right here. Because this over here, this with the square root of 19 is really no different than 4x plus 5x. Can I put those two together? Can I combine them? Yeah, they both have an x in it, So now I can write this as 9x. So whenever you have a square root and you're adding square roots together, as long as they have the exact same square root, you can put them together. So this would really be 9 square roots of 19. Now that you know that, look at the square root of 6 plus the square root of 6. Nope. But how many square roots of 6 do you have? 2 of them, right? So this would be 2 square root of 6. So it's just like saying x plus x equals 2x. As long as the square root is exactly the same, you can do that. On this one right here, we have a subtraction in it as well. But they all have square root of 2 in it. So it's really 4 minus 5 plus 7 is what? Yep. Yep. So it's going to be 6 square roots of 2. Okay, because 4 minus 5 is a negative 1. Negative 1 plus 7 is 6. Okay, we're working from left to right. All right, now we run into an issue here in this next one. They don't have the same square root. However, one of those haven't been simplified yet. So what we need to do is simplify it first. I can't simplify the square root of 3 because it's already down to its prime number. But this one, I can simplify down into this. So this would be like saying square root of 3 plus the square root of 2 times 2 times 3. I have a pair of 2's here that I can take one out. So now I have square root of 3 plus 2 square roots of 3. Now in this case, after simplifying, I have a square root of 3 on both of them, so I can add them together. Okay? So now I have a 1 square root of 3 plus a 2 square root of 3. That makes it a 3 square root of 3. And that's my answer on that one. There will be times in which that you simplify them and they still don't have the same square root. So say, for instance, you had simplified all the way down to this. I have a square root of 3 plus 4 square roots of 2. They don't have the same square root. So because they're not like terms, I cannot add them together. Okay? So I have to leave it like this. That would be my final answer in that case. That will happen sometimes. Okay, so if I go to break this down, 8 is the same thing as 2 and 4 and 2 and 2. So I can rewrite this as 7, 2 times 2 times 2. I have a pair of 2's here, and this is what's tricky because I already have a 7 on the outside. I'm going to take one of those 2's on the outside, multiply it, multiply it by that 2, and leave the other 2 on the inside. So now I have 14 square root of 2. Do the same thing for the 18. I have 9 and 2, 3 and 3. So this is like saying 4 square root of 2 times 3 times 3. I have a pair of 3's, so I'm going to take one of those on the outside. I have now 4 times 3 square root of 2. And this is going to be 12 square root of 2. Fortunately for us, they have the same type of square root, so I can actually subtract it. And then my final answer on this is 2 square root of 2. Okay, so now we have 27 that we need to break down into its prime numbers. So that would be 9 and 3, and then 3 and 3. So I'm going to rewrite this as 1/3 square root of 3 times 3 times 3. I have a pair of 3's, so I can take out one of those. So it'll be 1/3 times 3 square root of 3. What's a third of 3? Yeah, it's just 1, right? So I have 1 square root of 3 now. So let's do the same thing for 48. We have 12 and 4. 4 and 3. 2 and 2, and then I can break this into 2 and 2. So if I write this, it'll be 1/2 square root of 2 times 2 times 2 times 2 times 3. On this one, I have 2 pairs of 2. Because I have 2 of them, I'm going to take out one of each. And then leave that 3 in the inside. Okay, so 2 times 2 is 4. What's half of 4? 2. So 1 minus 2 is negative 1 square root of 3. The other way you could write this is just a negative square root of 3. And that looks weird because I know that naturally you want to repel that negative with that square root. But as long as the negative is on the outside of the bracket, it's fine. It's just when the negative is on the inside that you have trouble. Okay, so this is the answer on this one. We're going to rationalize the denominator. And remember, this whole section that we're working with, we are working with irrational numbers, right? Square root of 2, irrational numbers. So when they say they want to rationalize it, what do you think that means? So basically, they're just saying they're going to take an irrational number and make it rational. Okay? They're going to take a crazy number and make it a sane number, so to speak. Okay? So on this first one, in order to get rid of that square root, the easiest way to get rid of a square root is to multiply it by itself again, because that ends up being the number without the square root symbol. So this ends up being 6 on the bottom. But if I multiply the bottom by square root of 6, I got to multiply the top by square root of 6. So the top ends up being 45 square root of 6. The next step to this is to simplify. Okay, we have a fraction here in which both the numerator and the denominator is divisible by 3. So I can divide both top and bottom by 3. So this will be 15 square root of 6 and 2. And that is your final answer on that. We're going to go about and do the same exact thing with the second one. The denominator is irrational. We need to make it rational. So to do that, I'm going to multiply top and bottom by what? Yep, square root of 8. So this will be 18 square root of 8 over 8. One thing I've noticed is that this particular square root is not simplified yet. So I need to simplify that square root, and then I can simplify the entire fraction, or I can simplify the fraction and then simplify the square root. You can go either direction with this. So, but I'm going to simplify the square root first. So 18, 8, if you were to take it and break it down, and pretty soon you guys will get so good at this that you'll just remember it's got 3 2's in it, okay? So if I take out a pair of 2's, I'm going to have 18 times 2 square root of 2 over 8. That's the same thing as saying 36 square root of 2 over 8. Now, can I simplify the fraction? Yeah, because 4 goes into both. So 36 divided by 4 is 9. We've got square root of 2 there. And 8 divided by 4 is 2. So this is my final answer. Huh? Well, I know that 4 goes into 36 and 8. I'm just simplifying that fraction. Okay? Any questions? Okay, I got another problem for you. You know how to add them together. Usually with fractions, you have to have what? A common denominator. And unfortunately, this has not got a common denominator, nor does it have a rational denominator. So, either you need to rationalize both and then find a common denominator, or find the common denominator first, okay? So, I'm going to recommend that because I think it's a little bit quicker and easier to do that first, is to find the common denominator. I have a square root of 3 and a square root of 2. The fastest way is to multiply by the other denominator. So this will be multiplying by square root of 2 on both top and bottom. This will be square root of 3 top and bottom. When I do that, the square root signs fall away on the top of this because they're both square roots of 2. So this will be a 2. A square root of 2 times a square root of 3 is still a square root of 6. What will the other one be? 3 over square root of 6. Now they have a common denominator. So I can add it together and I have 5 over square root of 6. I cannot leave it this way though because it's got an irrational denominator. So in standard mathematics, never leave a square root on the bottom. So how do I rationalize this? Yep, I'm going to multiply by square root of 6 on both top and bottom. So the final answer on this is going to be 5 square root of 6 over 6.